The color of some of the fruits of Puglia that we have, it's really, they are fruits that are old, 100 years old and even more. And in this case, the color doesn't fade. You can verify yourself. The color really stands out and remains forever because it's not obtained using standard pigmentation that degrades in time, but it's a structural property of the material. And then you observe the strong blue color doesn't come from a pigment, but comes from cellulose.
I'm a biologist and I'm interested in how plants use various tricks of their development to attract animals, to disperse their seed and to disperse their pollen. Well, we don't understand yet how the plant can actually build the cellulose structures that make the colours. So if Sylvia can work out in the lab synthetically how to do that, then that gives us clues to take back into the plant to try and understand how the plant's doing it.
So essentially what you do, you start from pure cellulose, that is the same one that you find from the cotton fiber. You have to use acid in order to cut out part of this fiber, natural fiber. Acid dissolves the material. We let them evaporate in a controlled environment. We wait, and then you can obtain nicely colored film. And the color of this freestanding film is the same blue of the Puglia fruit because it has the same cellulose structure. So here we are looking at the structure of the Puglia fruit under the scanning electron microscope, and you can really see the anatomy of the fruits inside. So here you see the arrangement in layers of cellulose, and this arrangement in layers is exactly the same of what you can observe when you look in our film. It's not a perfect mimic, but this is the most important one from the optical point of view, at least in producing the coloration. So if you can make color out of this material, you can obtain also colors that are really brilliant and striking, like the case of the berry. And you use a material that in principle is cheap and really abundant.